Now we're going to take this function, defined from 0 to 2, of x squared minus 2x, and compute its area exactly using a definite integral. So first let's draw a picture of this function. I know that x squared minus 2x is the same as x times x minus 2. Finding the zeros of the function, then x equals 0 and x equals 2. So at 0 and 2, and this is a parabola, so that means the axis of symmetry is right in the middle. And when I plug in x equal to 1, then y is going to be negative 1. So my graph should look like this, and I'm finding the area of this region. I should notice right away that the area is going to be negative because it's all below the x-axis. Okay, so this time I'm going to use the right endpoints. Right endpoints happen to be my favorite or my go-to method. I just think it's the easiest way to do them. So my delta x is going to be 2 minus 0 over n, or 2 over n. That means my jumps are 2I over n. And since my a equals 0, then to get to the next point right here, it's just going to be 2I over n. That's why, especially if my limit, my low number in my interval is 0, the right endpoints are always easiest to use. It's because it's just whatever your jump is. So my c sub I equation is just going to be 2I over n. So setting up my limit, I've got the limit as n approaches infinity of the sum from I equal 1 to n of my function 2I over n squared minus 2 times 2I over n. All of that times my delta x. This is what I get. So I'm just going to work through this. This becomes the limit of my sum of, this would become 4I squared over n squared minus 4I over n, all of that times 2 over n, which is equal to the limit of the sum of 8I squared over n cubed minus 8I over n squared. Now I can separate that into separate limits, separate sums. So the limit as of 8 over n cubed of the sum of I squared minus 8 over n squared, the sum of I, which becomes the limit of 8 over n cubed times n plus 1 times 2n plus 1 over 6, using my rule, minus 8 over n squared times n plus 1 over 2, which becomes the limit of, I'm going to do some canceling here. This n cancels with this, and this becomes a 2. I can take a 2 out of this and a 2 out of this. And this becomes 2n squared plus 3n plus 1. I can cancel this n and one of those. I can cancel this, and this becomes a 4. So this leaves me with 4 over n 3n squared times 2n squared plus 3n plus 1 minus 4 over n times n plus 1. Distributing that, I get the limit as n approaches infinity of 8 thirds plus 4 over n plus 4 over 3n squared minus 4 minus 4 over n. Now, as I'm taking the limits of those, anything with an n in the denominator approaches 0 as n approaches infinity. So all of these approach 0. So the limit is going to be 8 thirds minus 4, which is negative 4 thirds. That's the area of that shaded region, and it is in fact negative.